Okay. So we're ready for example 1. Got all our background info down. We're remembering that we have no reference material at all, so we have to know that the sign is y over r, right? And then if we're in the unit circle, the sign is just plain old y since r is 1. All right, so here we go, example 1. Circle, center of origin, theta in standard position, terminal ray of the angle intersects the circle at point P. Here's the terminal ray of the angle. Coordinates of P are x, y. What's the cosine? Now, pay attention to this. What does that tell me? Since that's the point 3 comma 0, I know my radius is 3. And since this is the point xy, can't I label my triangle like that, left or right x, up y? So what's the cosine? That's an easy question. The cosine of theta is x over 3. That's it, x over 3. So what is that, A? All right, how about example 2? Now we've got a radius of 5, so our hypotenuse is 5. Theta is in standard position. Terminal ray down here in quadrant 4. If this is the point 3 comma 4, then what's this guy right here? 3 negative 4. And I need to find sine, cosine, and tangent. Find all of them. Now, if you want to go ahead and label the sides of your triangle, you can. If you are more comfortable with SOHCAHTOA, or you can just use your straight definitions. X is 3, y is negative 4, r is 5. So the sine of theta is negative 4/5. And the cosine is positive 3/5. And the tangent is negative 4/3. Now, what did I do there that confused you? Is anybody confused by that? We know our definitions. We've got our x, our y, and our r, so it's just a plug in. So let's
What angle are you looking from?
the angle. Okay, so the angle of the problem, theta, is this 4th quadrant angle. Okay? That one is not in the triangle though. So if I needed to say, if I wanted to do the SOHCAHTOA thing, I need a triangle with an opposite side and all that. I would be looking at this angle right here, which is called the reference angle. But that is not the angle of the problem. The angle of the problem is this 4th quadrant angle. It gets me all the way around to here, and that's why my y is negative. Okay, so using numbers here, if this angle were, let's say, 300 degrees, then this one would be 60. That's called the reference angle. And we kind of talked about that in our unit circle. We were doing it in radians, but this would be 5 pi over 3, and 5 pi over 3 has a reference angle of 1 pi over 3. So we talked about how all of the pi over 3's have the same x and y coordinates in the unit circle, because there are 4 pi over 3 angles. 5 pi over 3, 4 pi over 3, 2 pi over 3, and 1 pi over 3. All right. Okay, next picture. Example 3. All right, I need to figure out what's going on. Find the coordinates of the points in terms of x and y. Don't overthink this at all. What's the ordered pair for Q? Negative x comma y. Very good. And how about R? Negative x, negative and S x negative y. Everybody okay with that? Find the sine of the angle whose terminal ray intersects the circle at point S. So right here, I want to find the sine of that angle. The radius, remember, is R. I don't know what it is, it's R. What is sine? The sine is y over R, so negative y over R. All right, you do 5. The cosine at Q. What is the cosine at Q? Here's Q. Negative x over R. I can't tell if anyone knows what I'm talking about or not. Y'all good here? Hi. Okay. Find the tangent at R. The tangent at R. Tangent at R would be positive y over x because the negatives are going to cancel. Let theta, I'm looking at 7 now, let theta be an angle in standard position. Whose terminal ray corresponds with the line y equals negative 3x in quadrant 2. So here's the line y equals negative 3x. Tell me about these two sides right here. If the slope of the line is negative 3, can you identify some possible lengths here? What could these be? Could be negative 1 and positive 3. Could also be any of the numbers in that ratio, right? All of your trig functions are ratios. Number over number, y over r, y over x, whatever. So if I do 3 over negative 1, that's fine. I could do 6 over negative 2, but that isn't going to change the tangent. The tangent is 3 over negative 1. Notice that the tangent is the same as the slope. That is going to be one of the very first things you talk about in calculus class. Now, the tangent is the instantaneous rate of change, and it's the slope of the line. So it's also the first derivative, so guys in physics, you know that. All right, so I've got this picture, and I need to find the sine of this angle. Now, here's my angle in standard position. I want to find the sine of that angle. Well, what do I know? Sine is y over r. Now, I didn't draw a circle, but I could have. This is r, right? I don't know what r is. Can I figure out what r is? With the Pythagorean theorem. So, root 10. Quick comment. X and y can be negative. R will never be negative. R is positive. Okay? So remember that. R is positive no matter what. X and y can be negative. Oh, I shouldn't say that. Till we get to polar coordinates, then R can be negative. But right now, R is going to always be positive. So, what's the sign? 3 over root 10. Beautiful. What's the cosine? All right, 3.2 part 2. So the other day, when you were all resting at home and I was in here talking to my empty classroom again, I mentioned the word radiance. And when we labeled our unit circle, all of our angles were labeled in radians. That's how we do it in this class. But everything hinged on those special right triangles, 30, 60, 90, 45, 45, 90. So in radians, instead of 30, 60, we would read pi over 6, pi over 3. And instead of 45, we would read pi over 4. And that's all well and good, and I'm sure you're all working on getting all that memorized. But you're wondering, what is a radian? What is a radian? Well, first, let's back up. Anybody know what a degree is? You've been using degrees your whole life. What's a degree? Anyone know? What'd you say? 1/360th of a revolution. Now that is totally made up. 1/360th of a revolution. Could a degree have been defined as 1/400th of a revolution? Yeah. They just fascinated with those sixes and stuff, so they picked 360. A radian, on the other hand, has a very mathematical definition. So here's my circle, a random circle. Let's say this circle has a radius of, I don't know, 4. If I took a piece of string of radius length, so 4 units long, I took a piece of string 4 units long and wrapped it around my circle so that this right here, this arc, was 4 units long, the same as the radius. The angle that determines is 1 radian. So what's a radian? It is the measure of the angle determined by striking an arc of radius length. So every unit of radius that you wrap around your circle will create a radian. So this would be another radian. So 2 radians would have an arc length of 4, or of 8, right? 2 fours. Arc length is the product of your radius times your radius. So this is kind of a handy thing to keep in mind. We don't use it in fun, but if you're interested in the arc length, it will always be the product of whatever your radius is times the number of radians in your angle. Okay. Now, wait a minute. What's all the way around the circle? What do we call that all the way around the circle? It's called the circumference. And what do we know about circumference? Circumference is 2 pi r, and r is the radius. And wait a second, isn't this the whole arc? That's the whole arc. Is 2 pi times the radius. The radius times the radian measure of the angle gives you the arc. So what is all the way around a circle in radians? 2 pi. 360 in degrees, 2 pi in radians. They're all fit together perfectly. All right, let's try a problem. Let's look at example 1. Consider the angle created by the quarter circle above. The quarter of a circle. What would be its measure in radians? The angle, what would it be? What did you say about it? Pi over 2, it's half pi. straight up is pi over 2. If all the way around is 2 pi, then won't a fourth of that be pi over 2? Does it matter what the radius of the circle is? No, that's irrelevant. The radius would impact the arc length, but not the measure of the angle. A fourth of a revolution is pi over 2. How about a third of a circle clockwise? Remember, what is clockwise? Clockwise means we go this way. So my angle will be negative. And what would a third of a circle be? 2 pi over 3. So this angle, so negative 2 pi over 3. Remember, an entire circle, an entire revolution is 2 pi radians. So if I want a third of it, it would be 2 pi over 3. Right? But since it's clockwise, I gotta go down. Going down is so negative 2 pi over 3. Okay, now the unit circle, we've already talked about it, but look at that very last sentence at the bottom of this page. The concept of the unit circle will be pivotal throughout the rest of this course because of its incredible use. That's why I'm doing it all. All right, let's go to example 3. Sketch a picture of the arc length described based on a unit circle, then find the measure of the angle corresponding to the given arc length. Don't let that confuse you. It's very, very easy. It says we have a circle, which is a big arc length. A circle is nothing more than a big arc length, right? And we want to go a sixth of the way around, a sixth of the way, in a counterclockwise direction. So we're going to go up a sixth of the way. About right there, maybe. A sixth of the way around. And I want to know what's the measure of that angle. If this is a sixth of a revolution, then what is the measure of this angle right here? 1/3 pi. I'm going to say pi over 3, but that's the same as 1/3 pi. And who's been studying what would be the coordinates at pi over 3? What? 1/2 of 3 over 2. You are exactly right. Every pi over 3 angle, 1/3, 2/3, 4/3, 5/3. Every pi over 3 angle is going to have those coordinates. Sometimes positive, sometimes negative. Good job. 2 full revolutions clockwise. So here's my circle. 2 full revolutions clockwise. Going down, so I'm going to be negative. What would that angle be? 4 pi. Negative 4 pi. Why is it negative? Down, clockwise. Why is it 4 pi? Because I went around twice, and each revolution is 2 pi. 3/4 of a circle counterclockwise. 3/4 counterclockwise. Wouldn't that put me down here? What's the measure of that angle? In radians. 270 degrees, what would it be in radians? 3 pi over 2. 3 pi over 2. And on the unit circle, what are the coordinates of that point? 0, -1. Very, very good. 7/8 counterclockwise. So 7 Unit circle. 2 over 2. Negative root 2 over 2. So what's the tangent of 7 pi over 4? What's the tangent of 7 pi over 4? -1. Bingo, because what's tangent? Y over x. Okay, now we have our little unit circle here, and we've already done it, but go ahead and just fill in the rest of the angles around the picture. See if you can fill in just the angles in radians, of course, around the circle. You're not doing the ordered pairs yet, although you can if you want. Just going around that circle and filling in the angles. Pivotal is the word he used. Very, very important stuff. How do those look okay? Everybody get those okay? That's the beginning, and then we need to be able to attach the ordered pairs all the way around, which we'll talk more about that next time. Did I already assigned 3.1, right? Yep. All right, I'm not quite done with 3.2, so we'll wait on that one. And next time I see you people is Monday, and that's our quiz day, right? So we're gonna spend this weekend reviewing and ready. This is 1/3, this is 2/3. All right, I'll see you next time. All we'll do is a quiz.